Okay, so this is Codivate's fifth weekly video, and today is just going to be a review on what we covered the past few weeks, which is object-oriented programming. Okay, so the first thing we talked about was classes. What are classes? Well, in Python, a class is defined by the keyword class, and as you can see in the images, they are color-coded with the with blue, which is our IDE telling us that it's a keyword. We start off a class definition with the keyword class, and then we give it some kind of name. In this case, we gave it the name myObject. In the second image, you can see we gave it the name dog. This name can basically be whatever you want, but it is a convention to have it capitalized and in this kind of format. And then you follow by colon. The colon is special in Python because it basically tells Python that all the code which is indented from the colon basically belongs to this kind of class. So it's basically just to tell Python that this is part of this class. Okay, so classes are like blueprints. You can think of them as being blueprints to instantiate, which is just a fancy way of saying to create classes or to create objects. And essentially, each object and each class can have certain properties called attributes, which we covered last week. And if you need a refresher on that, you can check it out on our YouTube channel. And they also have actions or functionality, which are called methods. As you can see a few examples here. And notice that the pass keyword is just a placeholder in Python, since Python requires all bodies which follow a colon to have something. If you don't have anything, you can just fill in the pass keyword, which just tells Python to do nothing, but it's to avoid any errors. Okay, then we talked about instantiation, which, like I had said, instantiation is just a fancy way of saying to create or to create a new object. So you can instantiate an object by calling its constructor. You can construct an object using the constructor. And typically, this is how you do it. You have first example obj1, which is just the name we give it. We could have called it anything. We could have called it the letter A. We literally could have called it anything as long as it follows the rules of how you name. And we set it equal to example, and we call it like we would call a function. But it's important to note that the example isn't exactly a function in the truest sense, but it's called in a similar way. You can think of it as being a function that returns an object. However, that's not exactly how it works. You can instantiate many objects, so object 1, object 2, and object 3 are all separate objects, but they're constructed from the same class. So classes, this already shows that classes allow you to reuse code. We don't have to redefine example for each of these objects. We can reuse it for multiple objects. And each object will have its own state and attributes. And then we had class methods. Last week we spent a lot of time discussing the differences between class methods and instant methods, and we'll review that here. So the class methods, well, like the name implies, they're functions or methods that belong to a class. And they work exactly like normal functions. However, you call them by preceding the function call with example dot or the class name dot and then the method name. And it's important to note that the parameters you pass in will correspond exactly to the parameters in the function or in the method definition. So in this case, 15 corresponds to param1. And so it will print out 15 and then return 30. And basically, this function works just like a normal function. You can take an input from parameters, you can return stuff, you can do conditionals, all these things that you can do with a normal function. Then we talked about the init method. So the init method is actually the constructor. So remember when we called example, or in this image where we called dog? Well, where did that dog function come about? Well, it actually comes about from this init, the double underscore init method, also referred to a dunder for double under method. So this dunder method takes in the first parameter called self. If you remember, Self is the implicit parameter, and self basically allows you to, or self is basically something that's passed in automatically by Python. You don't actually have to do anything. So the two parameters, Cooper and Husky, don't actually refer to self and name, but they actually refer to name and breed, because name and breed are the explicit parameters and self is the implicit one. And here all we do is we set self.name, which is self.name is the attribute and name is the parameter. That's the key distinction. The self qualifier tells you that it's the attribute, while the no qualifier tells you it's the parameter. And then we can call my dog dot name, just like we do with functions, except we can call this. Okay, so like I said, the self keyword is implicit, but all the other parameters do have to be passed. If you don't, you will get an error. Okay, so instant methods are tied to an object. So we had previously mentioned 2 slides ago what class methods were. But instance methods behave differently than class methods. And the key difference between an instance method and a class method is the fact that instance methods have an implicit parameter called self. Once again, it's convention to call it self. It's not mandatory to call it self, but it's highly recommended that you do because everybody does. So the implicit parameter self will be passed in by Python. And essentially when you call an instance, so in this case rect for rectangle, if you call rect.perimeter, what Python's going to do is it's going to pass in rect, the object itself, as self. So then we can call basically rect.width and self or rect.length, because rect and self both point to the same thing. And so this will actually return 20 plus 30, which is 50, and then 50 times 2, and which is 100. So this print statement will print 100. So this also shows how you can access these attributes, because we actually define the attributes in the init method. But because it's tied to the self object, whenever we call self.width, it's actually referring to the one we defined in init. Even if self doesn't match, if we called this something, we could call, let's say we called this the word something. If we called something.width and something.length, as long as both of them end up pointing to the same thing, they will work as expected. However, because it can get confusing if you don't name it the same thing, Python, it's convention to call it self. So just get into the habit of doing that. And notice that even though this perimeter function has a parameter, because it's the implicit parameter, we don't actually pass in anything. We pass in 0 parameter because there are 0 explicit parameters. And then we talked about class versus instance attributes. A class attribute is usually defined at the class level and basically just has to do with variables associated with the class. So pi equals 3.14 is associated with this circle. And self.radius, on the other hand, because we define it using the self dot, that refers to an instance attribute. And this brings about the question, when would you use which? Well, if something's independent of each object, because pi will always be 3.14, it's independent of the radius. So this is a common place of where we would use a class attribute. But the radius can change for every object. One object could have a radius of 3, another could have a radius of 5. So in that case, you use an instance attribute. And so this is how the kind of questions you want to ask when deciding when to use which one, because it can really help you narrow down and make the best decision. Lastly, we talked about references, and essentially what references are how Python stores values. So even though we have the value x equal to the array 1, 2, 3, it doesn't actually hold the array or the list 1, 2, 3. What x actually holds is the memory address of where 1, 2, 3 is located. So on your hard drive, on your RAM, this list will be stored somewhere. Let's just say it points to the address A123, which is a common example, but it likely isn't. But let's just assume it's located at A123. X doesn't hold the list 123. It actually holds A123. Or that might be confusing, so I'll call it A567. Okay, X actually holds A567, not the array 123. So when we say Y equals X, we're not saying Y equals 123. We're saying Y is equal to whatever X holds, and X happens to hold A567. So Y will also hold A567. So this is why the print X is Y prints out true, because if you remember, the is keyword actually checks if two references are the same. So it checks if Y and X both contain A567. It doesn't care about the value. The double equals sign checks equality. That checks whether two values are in fact equal. So X is Y is true, because both of these do point to the same thing. However, if we both independently assign, let's say A and B, to the list 1, 2, and 3, they both point to different addresses. A could point to A567, and B could point to Q348, for all I care. These are two different memory addresses, and therefore A is B is in fact false. So this is important to know and understand, because it can lead to a lot of bugs. You may do something like this, and then you'll realize that if you modify X, you'll actually unknowingly modify Y, because they both point to the same thing. X points to 1, 2, 3, so if you set X index 2 to the number 4, Y index 2 will also be swapped because of this sort of relation. They're basically tied together to the same memory value. So this is why it can get a bit confusing. You may have bugs. So it's important to understand this key distinction between is, equality, and references. So then we have common mistakes. Like I had said, in the first one, if we call a method off of an object which doesn't have the implicit parameter self, you'll get an error, because Python will always pass in self whenever you call it off an object, and test method has no such parameter self, and so you will get an error. It'll say it required one parameter but zero, or it required 0 parameters but 1 was provided, or something along those lines, and that's a common error. Another common error is when you try to modify a value based on the references, because remember, when I had mentioned in the last slide, X holds hello world, Y equals X, and X plus equals again. So printing Y still prints out hello world. And this has to do with the fact of immutability, which I think we talked about last week, but I won't get into too much today. But in this case, if we have A equals 1, 2, 3 and B equals A, doing A.append 4 actually modifies B, because both of them point to the same list. They both point to basically to some memory address, let's say A567. And so trying to modify A will unintentionally and indirectly modify B. So it's a common mistake that a lot of beginners will make, and it's important to understand this distinction. These are our exercises to test your understanding on object-oriented programming. Here we have a cylinder class with a radius and a height property. Remember, you have to consider whether or not it'll be a class attribute or an instance attribute, whether or not it can change based on the type of object or based on each object, and have methods that can calculate volume and surface area. If you're not sure on the formulas, you can Google them, and you can find probably the first result will get you a formula on how to calculate this. That's our first exercise. Our second exercise is to create an animal class that has two properties, a species and a sound property. And both of these properties can be strings. So like a species could be like something like a dog, or you can even get more specific, like a retriever or something like that. And then you can have a sound property, which is like what they make. So like a dog will go bark, a cat will go like meow or something like that. And then what you want to do is you want to create a for loop that creates a total of 100 different objects with unique properties. And you can choose how to make them unique. So for example, you may have a list of different species and a list of different sounds. And then you can choose randomly from that. So this is also testing your whether or not you understand how to use the random class. Then you want to basically just append each object to the list, to a ongoing list. And this will test a lot of things. It's testing whether you know how to create an object, whether you know how to use the random property, how methods work, and all these stuff. And lastly, we have exercises about finding the error. So in this code example here, we have counted 6 different errors. You may count 7 if you consider some things to be slightly to count as 2, but you should get roughly this amount. And the key is to not use an IDE. So try to do it just by looking at this and see what the potential errors are. And those are our 3 exercises. And this presentation was owned by Codivate. It is our 5th presentation that we post weekly. If you have any questions, once again, you can either email us as internpi@codivate.org, but we highly recommend you join the Discord so you can like reach out to your tutors almost instantly, and you can get any questions answered, and we highly recommend you join our Discord.